Hi all, this is Saranya from KIT Kalaignar Karunanidhi Institute of Technology, Coimbatore. So today I am going to take the topic convolutional neural network. So convolutional neural network is the extended version of artificial neural networks which is predominantly used to extract the future from the grid-like matrix dataset. For example, visual datasets like images or videos where data patterns play an extensive role. So first the image is given as an input layer, in the input layer, and then convolutional layer, after that max pooling layer, and then dense layer, and then we are extracting the output. How convolutional layer works? Neural networks or convnets or neural networks that share their parameters. Imagine you have an image. It can be represented as a cuboid having its length and width, dimension of the image, and height. The channel as images generally have red, green, and blue channels. So, so cuboid, if you are giving the image in the convolution network, it will calculate the three positions. So it will be generally represented in three dimensions. For example, length, width, and then height. So mathematical overview of convolution. Convolution layers consist of a set of learnable filters having small width and height and the same depth as that of input volume. For example, if we have to run convolution on an image with dimensions 34 into 34 into 3, that means 34 cross 34 cross 3. That means length, width, height. The possible size of filters can be A into A into 3, where A can be anything like 3, 5 or 7, but smaller as compared to the image dimension. During the forward phase, we slide each filter across the whole input volume step by step, where each step is called the stride, and compute the dot product between the kernel weights and patch from the input volume. As we slide our filters, we will get 2D output for each filter. We will stack them together as a result. We will get the output volume having a depth equal to the number of filters. The network will learn all the filters. And the next layer is used to build the convnets. A complete convolution neural networks architecture is also known as convnets. A convnet is a sequence of layers, and every layer transforms one volume to another through a differentiable function. So types of layers. There are different types of layers. First one is input layers, convolution layers, activation layer, and pooling layer. So now we are going to see one by one. Input layer. It's the layer in which we will give the input to our model. In CNN, generally the input will be an image or any sequence of images. This layer holds the raw input of the image with width 32, height 32, and depth 3. Convolutional layers. This is the layer which is used to extract the feature from the input dataset. It applies a set of learnable filters known as the kernels to the input images. The filters or kernels are smaller matrices, usually 2 cross 2, 3 cross 3, 5 cross 5 shape. It slides over the input image data and computes the dot product between kernel weight and the corresponding input image patch. The output of this layer is referred as feature maps. Suppose we use a total of 12 filters for this layer, we will get an output volume of dimension 32 cross 32 cross 12. Next, we are going to see about the activation layer. By adding an activation function to the output of the preceding layer, activation layers add non-linearity to the network. It will apply an element-wise activation function to the output of the convolution layer. Some common activation functions are ReLU, maximum of 0, x, tan h, leaky ReLU, etc. These are all actually used to calculate the activation functions. The volume remains unchanged, hence output volume will have the dimension 32 cross 32 cross 12. Pooling layer. Next we are going to see about the pooling layer. Actually in pooling layer, periodically inserted in the coordinates, and its main function is to reduce the size of volume, which makes the computation fast, reduces the memory, and also prevents overfitting. Two common types of pooling layers are max pooling and average pooling. If you use a max pool with 2 cross 2 filters and stride 2, the resultant volume will be dimension of 16 cross 16 cross 12. So see here a simple example of max pooling is given here. In the given single depth slice, so the height which is represented as x and width which is represented as y, in which it is a 4 cross 4 matrix. Okay, so 1 1 2 4 5 6 7 8 3 2 1 0 1 2 3 4. This is a single depth slice matrix consists of this values. So in which I need to identify the max pooling. So I am taking the straight value of 2 cross 2 filter. Okay, straight value of 2. So I need to calculate the max pooling. So I am taking the straight 2. So I have to separate the given matrix into 2 cross 2. Okay, straight 2 mean I need to separate it with the 2 cross 2 matrix. So 1 1 5 6 is one matrix, and 2 4 7 8 is one matrix, 3 2 1 2 is one matrix, 1 0 3 4 is one matrix. I need to find the max pooling. So I need to find the maximum value in the given 2 cross 2. So 1 1 5 6 I got the maximum value 6. I took this maximum value 6. 2 4 7 8 I took the maximum value 8. 3 2 1 2 I took the maximum value 3. 1 0 3 4 I took the maximum value 4. So this was the way I need to calculate the max pool. And the next, flattening. The resulting feature maps are flattened into one-dimensional vector after convolution and pooling layers. So they can be parsed into completely linked layer for categorization or regression. Fully connected layers, it takes the input from the previous layer and computes the final classification or regression task. So here the input is given, core image is given, it is given to the coordinates, and then for each and every patch of the coordinates at the between we are calculating the pooling values also, and then the given image is trained to the convolution neural network to identify whether it is a core, truck, airplane, ship or horse, and then with the given image in the convolution neural network it extracted the pixels, and then with the trained images it identified the given image is the core and then output layer. The output from the fully connected layers is then fed into the logistic function for classification tasks like sigmoid or softmax, which converts the output of each class into the probability score of each class. Okay, so this is what about the convolution neural network. Thank you all. We will meet in the next class. Thank you.